Yo, what's up, everyone? Second lesson of week 5, and today I'm going to be honest. We have a pretty tricky lesson, but because what I'm teaching I think is kind of hard, I'm going to try to make sure the video isn't too long. Okay, so sometimes I make a long video that's not too difficult, but this concept, especially the second example, is a little difficult, so I'm going to keep it to that. Um, However, it is interesting, and I think that we're doing really well so far. Even though we're doing online school, I feel like this is kind of the best my Algebra 2 has ever done, and a lot of people are really liking what they're learning and kind of responding well to it. So we're just going to continue with that. So for this first example, there's not a lot of writing. It's mostly a thought experiment. It just says, look at the following 5 graphs. Identify which graphs are functions and which are not by using the vertical line test. Now, this concept of functions we're going to talk about today, and we're going to continue to talk about next week. But know that graphs can be legal or illegal. Like there's a right and a wrong way to do a graph. And if your graph is correct, we call it a function. And I know that seems kind of weird, like what do you mean by right and wrong? But there are certain things that an equation and a graph have to do in order for it to be allowed. Okay? And if it follows really pretty much just this one rule today, then we're going to consider it a function. And that's what the vertical line test is. Okay? So first, we hear the word function all of the time, but I also want you to think that if a graph is a function, we can use f of x instead of y. Okay? So f of x, what it really stands for, we see this all the time and it's been confusing so far, it means a function of x. So if our graph is true, if our equation is legal or it works, y is a function of x, meaning that every single y value comes directly from x. You plug something into x and it solves you y. Okay? So y is a function or like a result of x. That's why we call y the dependent variable. Okay? So we have to figure out what has to be true for it to really be a function. And the key to that is that, and let me write this and then I'll say it. And for it to be a function, all that needs to be true is that every x value has exactly one y value. And what I mean by that is when you plug something into x, the input, it has to give you back exactly one answer for y. So the easiest way for us to think about that is for b. If we're looking at a, for each of these, we're just trying to figure out if it's a function or not. So a is a function because it looks exactly like all the graphs we've done before, right? And this is perfectly valid, right? You put in any x value from negative infinity to infinity, and it's going to give you one y value. So a, yes, function. But then what's wrong with b? And we have a piecewise here, and again, if you see one that goes all the way, it possibly can. So this like hits this top of this, and this hits this. Please put the arrows in because I gotta figure out how to have arrows. Like I copied this graph from somewhere. I gotta figure out how they did that. I gotta use this function, not Desmos. But yeah, we want arrows both ways. And what's problematic about this graph is that a lot of x values are right in the middle here. Two things are happening at the exact same time. Okay? So if you're looking, it starts off fine. But then usually if this was a piecewise, we would stop here if we're going to go over here. But the graph has two values at the exact same x value. So left to right, it passes through the same point. Okay? So at 0, when x equals 0, what does y equal? It equals -4 and 5. And you can't have that, okay? For it to be a function, every x value has to have exactly one y value. If there's two y values, this isn't a function, and this doesn't work. And the easiest way to look is what we call the vertical line test, which I've kind of been alluding to, but the big problem here that isn't true here is that we pass points on x twice, okay? So if you can ever draw a line on your graph, a vertical line, and it hits your graph twice, that's what we consider illegal. Okay, so this graph is illegal because we hit it twice, and it's not a function. And that's really the extent to which I'm going to ask you about functions today. If it fails the vertical line test, it's not a function. Here, every single spot has exactly one value, right? These random lines show that you only hit it once, you only hit it once, you only hit it once. But here, we hit it twice. Now, this second example, or second two, C and D, are going to highlight something that we've missed that's really fundamental. And that's why it says harder piecewise. So today will be the last piecewise lesson. We're going to talk about some piecewises that we've missed. But first, we're looking at something we actually haven't seen. And that's like a gap in our data, right? And it's not just going here when it changes at the same point and going up, and then the same point going down. Here, we travel, and then we move, okay? And we want to figure out, is this legal? And before we can do that, we have to talk about open versus closed circles. Okay, so this is really important. At the end of our graph, if it just continues on at the same point, you don't have a circle, okay? But a gap, which sometimes is legal, sometimes is not legal, is going to have two kinds of ends, right? We're going to have a closed circle and an opened. And if we have a closed circle, that means it equals that point, okay? So here, this point works, which is 2 comma negative 9. 2 comma negative 9 works and is a point on the graph because this circle is closed. So closed means point is on graph. And I'm really excited about the rest of this. This is going to be dope. So here, this is a point on the graph, but this 2 comma negative 3 is not technically a point on our graph. What this open circle means is that this part of our equation goes all the way until we get to this point, and then it stops and doesn't hit the point. Okay, so we talk about infinity a lot, and we'll talk about, or eventually we'll get to maybe limits, the concept of limits, but think that you're going to approach this point but never get to 2 comma negative 3. So an open circle means not on graph. So in the case of C here, C is a function. And the reason is we have a gap, but we don't care about that gap because X is not being double counted. You're allowed to have space. The problem is having double. So there's no double here because our graph goes here. We hit this point. It doesn't hit this point. So when X is 2, it equals negative 9, not negative 3, but then we continue. Okay, so this is a function. I think that last thing I said wasn't perfect, but it will make sense when I contrast it to D. So the problem with D here is we have 2 closed circles, okay? And that means both of these points are part of our function. So this is halfway in between the two. There are some halves here, so we'll just do some 0.5 stuff. This is a point on our graph, again at 2 comma 2.5. This point is 2 comma negative 4. But what's happening is that both of them are points on our graph. So if we're going to look at failing the vertical line test, B was not a function because when X is equal to 0, for example, it was 2 things. So here, if I say when X equals 2, what does Y equal? We're going to fail because it's both of these things, right? X at 2 is equal to 2.5 and negative 4. So this is not a function, and now this is a great part. It would fail the vertical line test. My line's not perfect, but think that it hits this point twice, and it can't hit any X value twice. So because we have two closed circles equals not a function, okay? And so this is not a function. This one passes the vertical line test because it is this point and it's not that point. So two closed circle doesn't work. One closed circle is good. And actually two open circles, so no closed circles works as well. But we're going to get into that in a second. Okay, so here's the final one. This and the example, if you notice, are the hardest it's going to get, but then we're going to be done. And this asks, is this a function? And I realize this isn't exactly what I want, but that's fine. Here, we have to talk about what's okay and what's not okay. Now, this isn't going to be a function, right? Because we fail the vertical line test. However, my intent and what I really want to talk about is this side. And what you're going to notice about this that's different is that there's a gap in data, right? X doesn't equal anything from from 4 to 6. So the question is this allowed? And the answer is yes, okay? If you can draw a vertical line through without data, that's totally okay. The only problem is if you have more than one point at the same spot. But you can always have gaps. So I'll write that. But gaps are legal and doesn't affect whether or not it's a function. But they are going to affect domain and range. So that's kind of where we go into the next part of this, because we have to figure out what we do with these open and closed circles. Okay, so this is the second part of the lesson, and this is going to be really, really important because we're going to talk about some more difficult domain and range questions. So we're going to roll through A, B, and C to start. And at first it just asks us, is the graph a function? So you might be noticing, like, we're developing the types of things we can ask about a graph, but the first thing you always would kind of question is whether or not it's a function. And what we have to think here is, does x ever equal the same thing twice? And our concern first is usually going to be where our equation changes. So we change at -5, but we only have one closed circle, so this is good. And then here, there's a gap, but we don't care about the gap. The gap is fine. There's no point where we're double counted. So we're going to say yes, and if it asks you why, the answer is the vertical line test. You passed it. Okay, and now we're on to domain and range. So for domain, we know that domain is x and range is y. And we're trying to figure out what is possible both directions. So from left to right, what numbers exist and what numbers don't exist on my graph, and same up and down. So I'll start on the bottom here, and we're going to think about x. So we're trying to figure out, is every x value from -infinity to infinity possible, or do we ever stop? Do we have any gaps? We've only had a few examples where the domain is at -infinity to infinity, so this is kind of a second way to think about it. And again, it's all about where we stop, or where the breaks are. So first, nothing is stopping my graph from traveling from -infinity all the way until I get to -5. Okay, so just think this goes forever to -infinity. So this part of my domain is good. Here, it looks kind of funky, but let's think that x does equal -5 and continues. It all works, right? It's only -5 once, so we don't even need to write this. My graph is just continued, okay? Hopefully that makes sense to everyone. Nothing has stopped my graph. It's every single x value up until we get to this point. So once my graph travels here, there's a break in it. When we get to -2, x equals -2, but not, sorry, I keep saying -2, but x equals 2, but it doesn't equal 2.1. It doesn't equal 2.2, 2.3. It doesn't equal anything until we get to here, which is 4. So domain is always reading from left to right. The graph continues perfectly until we get to 2, then it stops, and then it picks back up at 4. And at 4, think it's just going to continue forever, right? It's going up and to the right forever. So we're trying to figure out how we write this, okay? So let's start on the left side. We know it starts at negative infinity. And the first time it stops is when we get to 2, okay? And now we have to figure out what to write. And the second huge part of this lesson is parenthesis versus bracket. So I've been kind of neglecting that topic and waiting for it for now, and I think it's going to make sense. But what happens at 2? The question is, we stop there, but does it equal 2 or does it not equal 2? And if it equals that number, so it is 2, we put a bracket sign. So let me write that on the bottom as notes. And if you see a bracket, that means equal, okay? And let's talk about infinity. We use the not equal sign because the concept of infinity is that we never get there. We just keep going forever, but we can never reach infinity, right? So this is an open circle because we're going to go all the way to negative infinity. We never get there, but then we equal 2, and then we stop, okay? But that's not the end of our graph. This would be the end for a lot of functions before, but now we kind of want to talk about what happens here. And we have similar stuff, right? From 4 to infinity, there's action. So if there's ever a break, you're going to use this U. And that's the most technical, annoying part about this. So this U means union or and we're going to say it's this and 4 to infinity. We stop from 2 to 4. We aren't that, but we pick back up at 4. Now this is an open circle, so what do we do about the bracket versus parenthesis? We're going to use a parenthesis because it doesn't equal that point, okay? So everything, think 4.0000001, the number right next to 4, it does equal that. But when we hit 4, it doesn't equal that, so it's an open circle. Not open, my bad. Soft parenthesis, not a bracket. Hopefully that makes sense to everyone. I'm really proud of you because this is complicated and I think really cool. All of that was left to right, and range is going to be top to bottom. So I'm going to write it here now. We're tasked with the same thing, and there aren't going to be too many new skills here, but we're trying to figure out what's possible if we go from down to up. And the graph starts down to negative infinity, again until we reach negative 5. Now this is interesting. Since there's no data here, we have to put a break, right? Y can never be 2. Y can never be like negative 2 or negative 3. It's never going to be any of these things. So once we hit negative 5, we're going to have to stop until we hit what? The next part of our graph is at 0. So if we're going down to up, we go from negative infinity, or the bottom, all the way to negative 5. Then we stop from negative 5 to 0. And then from 0 forever, it's going to be infinity. And you can have two y values that are the same. That's totally valid. We don't care that it's double counted here, as long as x is only one thing. So if I'm going to draw or write this range, I have the same concept. We have two different parts and a gap in the middle. So let me write the numbers, negative infinity to negative 5. And I left this and this blank because we just have to think about the closed or open circles. And it's always these soft brackets or parentheses for infinity. But for negative 5 and 0, think that because this is an open circle, it doesn't equal those points. So the only time you have this hard bracket is when you have a closed circle. If you have an open circle, it's going to be a soft bracket. So that would be the range. Hopefully that makes sense to everyone. So for this final thing, we have to write the piecewise, and I'm actually not going to make you do that. And actually, here's what I'm going to do. I'm just going to find the equations because I've done that a million times, and I'm going to put them here. So if you want that challenge, pause the video and find your equations, because all I'm going to talk about is the intervals. Okay? Okay. So those are the equations, but what I want to talk about is how to write these intervals now that we have open and closed circles. So I think this is going to be pretty quick, but again, this piecewise has 3 parts, and we want to write where they happen. And remember that this is actually going to perfectly line up with the domain. So the first one, this section, starts from negative infinity, and when we write the piecewise intervals, we use the second notation. Okay, and because it doesn't equal negative infinity, we just use the less than sign. And here, because it doesn't actually get to -5, we're just going to use the less than sign again. So what this means is x equals everything in between negative infinity and -5, but it doesn't equal those two values. Okay, so I think you guys are like much more used to using less than signs versus less than equal signs, but that's really the end of this video. Okay, so if you see an open circle, it's going to be a less than sign, but if you see in a closed circle, it's going to be a less than or equal sign. So here, this second set, the second equation, goes from -5 to 2, right? -5 to 2, and it equals both of those values. It equals -5 because it's a closed circle, and it equals 2 because it's a closed circle. So if I'm going to write this, I'm going to use 2 less than or equal to signs. And my function works perfectly all the way from negative infinity to 2 because we have 1 less than or equal to sign. If both of these were less than or equal to signs, this actually wouldn't be a function, okay? And I may have done that in the past as an accident, but only one of them can be for it to work. Open circle, then closed circle. Okay, then finally we have this last section, which goes from 4 to infinity, and it doesn't equal 4. You always use no equal to sign for the infinities, but it's an open circle, so it's going to be a less than sign. And then this and this are always going to line up. Negative infinity to 2, and then 4 to infinity. So that would be how you write that equation. So I said at the beginning it was going to be a short video, and that didn't happen. But I really, really appreciate you because this is probably the hardest lesson to date. And it'll get a bit easier for the rest of the unit. So excellent work. Proud of you. Woo.